So first of all, rigid couplings are used only when there is perfect alignment between the axes of the two shafts. So when the axes of the two shafts are perfectly aligned, there should not be any misalignment between the two shafts. There we can use rigid coupling and motion is free from vibration and shocks. So there we can use the rigid type of coupling. Now, misalignment exists due to the following, due to the certain reasons. Means when I say there is misalignment, that is because of the deflection of shafts. When now here you can see there are two shafts, shaft number one and shaft number two. So as uh, if there is deflection of shaft due to the lateral forces, or there is error in shaft mounting due to the manufacturing tolerances. Also, use of two separately manufacturing units such as electric motor and gearbox, or you can say worm gearbox. So because of these few reasons, there is misalignment exists. If the rigid coupling is used in such cases where there is misalignment, so that causes excessive bearing reaction and resulting in vibration and wear. So whenever there is misalignment between the shafts, now there are certain types of the misalignment. Now I am writing on paper. Just you can see this is the called as lateral misalignment. Whether it is visible to all of you? Yes or no? Whatever writing on paper. So this is shaft number one and this is shaft number two. This is shaft number one and this is shaft number two. So there is misalignment which is called as lateral misalignment. So you can say this distance you can say delta, or this distance is delta. So this is misalignment. In such cases we cannot use a rigid type of coupling. There we can use flexible coupling. This is one type of misalignment. Another type of misalignment is, here again I draw another diagram which is called as axial misalignment, which is called as axial misalignment. So this is the axis. Now here you can see the distance is delta, so that is lateral disalignment, lateral misalignment, and here this is the axial misalignment. So this distance, this is called as axial misalignment of shaft. So this is axial misalignment of the shaft. Also, in certain cases there is angular misalignment. In certain cases there is angular misalignment. So here you can see angular misalignment. So this is the angular misalignment. So certain angle is there. So in such cases, we can use the pushed pin type flexible element. So this is called as flexible element like. Now here you can see. Here is the only change that we are using flexible element like rubber bush between driving and driven flange. So here there is a rubber bush. Also there is pin and brass lining. हे क्रॉस सेक्शन लाईन्स ज्या दाखवलेल्या आहेत. सो कॅन सी इन स्क्रीन मध्ये बघा. So here this is the flexible element that we are using, which consists of pin and a rubber bush. Inside that rubber bush there is a brass lining. So there is length of the rubber bush. So this is called as flexible coupling, which is using flexible element. Now, what are the advantages of this using this one, which is called as bushed pin type flexible coupling? Now, first we can it can tolerate 5.5 mm of lateral or misalignment, 0.5 mm of lateral or axial misalignment. म्हणजे here on paper you can see this is the lateral misalignment. So if there is 0.5 mm variation, that is if lateral misalignment is there through this 0.5 mm, we can use this flexible coupling. Also axial alignment म्हणजे दोन ऍक्सिस मधलं हे जे डिस्टन्स आहे शाफ्ट 1 आणि शाफ्ट 2, so to that distance 0.5 mm we can use this. Also angular displacement, angular misalignment 1.5 degree. So here 0.5 mm allowed, 0.5 mm allowed, and here 1.5 degree, 1.5 degree, 1.5 degree. So it prevents transmission of shocks from one shaft to other shaft and absorbs vibration. It can transmit high torque because of absorbing these shocks from one shaft to other shaft. So this is regarding the bushed pin type flexible coupling. Now in the next figure, now forget about the notations used over here. Just I have shown this for getting additional information. Forget about what is D, capital D. What we are using, that I will explain regarding the symbols that we are using. But here you can see here 4 holes dia 0.3 D. So this is over. This is left coupling and this is right hand side coupling. Here you can see the change. There we can use a rubber bush which is having inside brass lining, and here there, so which is, and there is pin with the help of this. So here in the previous diagram you can see here this is pin. So and here there is nut. So a rubber bush, inside that there is brass lining, so that you can adjust whatever we can say, that lateral misalignment, axial misalignment, or angular misalignment. So with the help of this, that can be allowed. Now this is capital DB. In this figure you can see capital DB, that is the diameter of the bush. Capital DB is the diameter of the bush. Next figure we'll see, this is cross section, and here again forget about the dimension that written over here. Only you can see the how that rubber bush and pin arrangement is there. So with the help of this we can adjust whatever alignment allowed, that is lateral, axial, or angular misalignment. Okay, so you can see only figure. Now in the next figure clearly you can see there is a rubber bush. Here this is a rubber bush, brass bush, or you can say brass lining up 2 mm thickness. This is the length of the bush, and here D1 is the diameter of pin, म्हणजे जो pin चा diameter आहे. So here you can see this is the D1, that is diameter of the pin. So this is regarding rubber bush that we are going to use. Again we are having the figures. Okay. Coupling, only the change in flexible coupling is we are using flexible elements. Now we can go for analysis of flexible coupling. Now here it is assumed that the power is transmitted by shear resistance of the pin. Here we can assume the power is transmitted by shear resistance of pin. Now here is the figure how that is transmitted, or how analysis of that. You have to concentrate on that brass bush, or you can say rubber bush. That is the only design part in this bushed pin type flexible coupling. So in analysis of flexible coupling, it is assumed that power is transmitted by shear resistance. So couples due to resistance force with the torque, as in rigid coupling we have seen this diagram. So here I will draw that again. Once again I will draw